All right, then. Thanks for dropping by. This is now the third session of the practical course on flexible human-AI interaction. I just wanted to sort of step back in where we left things off last time. So some of you were here, I remember, and the last session we spoke about this whole trade-off of automation versus control. What do we give to a computer to decide or to a system to decide, and what do we keep in the hands of a user? And at the end of the last session, you looked at this a little bit of a crazy, provocative decision support system for an imaginary digital health use case, which was decisively bad, and we criticized a little bit the potential impact and outcomes of such a system. And I gave you this tool, Sheridan's scale of automation, to think about, where you can say, okay, either a computer offers no assistance whatsoever, or it automatically does what it does and completely ignores any user input. And between that, there are all sorts of levels of how much information or involvement is given to a user. Really helpful to think about these different types of systems, as we can differentiate the extremes of a scale, focusing on very efficient direct manipulation tools, 100% predictable, very reliable, limits to what they can automate, or sort of more dynamic systems with sometimes unpredictable outputs that can automate different tasks. So we also spoke about errors and error recovery a little bit. Yeah, in this whole context, I wanted to point out another sort of an interesting theory or thought. We just spoke about these levels of automation, and I'm yet to set up a study and prove this, but there are some interesting ideas being circulated. When you think about this concept that I just mentioned, the rather sort of non-interactive is actually wrong, the non-autonomous system versus the fully autonomous agent. At the same time, there is a scale you can open up where I think there's at least some connection there with a system where the system does not take autonomous decisions. The responsibility for a system's actions is always on the user, right? Sort of like I fired a gun situation. Whereas the more you automate a system, the more likely the locus of responsibility shifts, or especially can be shifted in how people understand themselves and their own responsibility and actions. So the more automated, the more agent-like the system, the more likely it is that responsibility, or the locus of responsibility, will be placed with the system, as in the system decided to shoot. Yeah. So this is really important, I think, to think about. Again, I would love to do a study and have some concepts, so let me know if you're interested around this connection and how it could be shown. But I think it's a really important thing to think about as we go on and automate systems more and more. So when should we then use machine learning or AI to do these highly automated tasks? It's certainly a case-by-case decision. There's a list in further detail in the slide set, which is, as always, in the online space. So you can look this all up in your own time as well. But case-by-case decision, but generally when it's really, really beneficial, when direct manipulation does not solve the challenge, and when biases and risks can be managed. And that's just a recap of the last session then. So we spoke about both feedback and control, as well as errors and graceful failure or recovery. And again, here are pointers to the relevant guidebook, this one, the one being written by the PAIR team at Google. Yeah, we can observe human AI interaction is an emerging crossover of HCI traditions, sort of engaging with machine learning and AI. There are some definitions there in the beginning. Systems with difficult or impossible to predict outcomes, or systems that challenge many traditional usability and user experience paradigms. We went into a lot of detail in the last session. And there are system risks, potentially critical errors. So recovery strategies or prevention strategies are really important. So yeah, last time I already said, in this session, we will focus on biases, fairness, explainability, and other, I call it X-ability concepts in the context of human-AI interaction. So let's jump right into that. Just a kind reminder, this is, as I said in the beginning, these sessions are pulled out of a larger lecture series. So I'll be very quick running over the materials. The full slide set, you can download that yourself to look at details, look at links. And if you have a problem understanding things, step up on the podium and ask a question, or write me a personal message if you would prefer that in GatherTown, and I can see if there are questions around understanding the slides, and there'll be time to discuss things later on as well. So in the first session, I talked about this famous gender shades study, right? This where it was shown that systems have a much higher classification error for darker skinned people than lighter skinned ones, and especially darker skinned females, having the largest percentage gap in terms of system prediction accuracy here of 34.4%. And this is an example that gets cited a lot, why we should care about biases and also fairness and responsibility in human AI interaction. This study was actually done by, a team, but Tim McGivern was one of the authors. And I'm not sure if you follow these developments closely, but there was a big scandal in Google research, actually, where Tim McGivern there was an internal fight with Jeff Dean, who leads Google research. And there was this forced or pressured resignation over an AI ethics paper. So this whole topic area is really dicey for a lot of organizations, because there is a lot of goodwill and movement into the direction of recognizing the importance of biases, fairness, ethics in a larger context. But it's also a struggle for those organizations that build the largest systems and stand to gain the largest profits. The gender shades example I showed is it's pretty apparent why that's an issue that we need to talk about. But just to give you some more examples that really drive the point home that this is an issue in operation. There's an example with sort of in studies showing that Google Ads display more high-paying jobs for male users than for female users. Or in another example, in a system about predicting how likely somebody would be to be reincarcerated after release, there's a predictive system in this space, which is highly problematic to begin with. And the system for African American defendants, it was substantially more likely than for white American defendants to incorrectly classify them as high risk for reincarceration. And there's some links to follow up with this material if you're interested. I think it clearly shows the issues. If we talk about biases and fairness, just some points for clarification. So bias really meant as in prejudice in favor or against a person, group, or thing that is considered to be unfair. We frequently see bias in classifications and predictions in machine learning and AI systems. This is very often due to the underlying data sets, which already have a bias in them in terms of usually there just being more data, better coverage on certain parts of the population than on others. Sometimes the bias can be introduced in processing. Most of the time it's actually in the data. And there are now a lot of algorithms and methods in development to analyze and check for such biases. So that's a positive development. By and large, I would say these are currently two different strands. There's one research strand saying we need to care about this, and there's the other research strand about methods development and also applied systems, which is slow in picking up these ideas. But some of it is happening, so some changes there. This is an interesting point to make, that it's very difficult to automate the decision on whether a system has some bias. And in particular, it's difficult to automate whether a system's processing is still fair, because that's a complex judgment call that arguably may, at the end of the day, always require some humans in the loop. And we'll talk about humans in the loop as a concept in a second anyway. But yeah, just some issues, of course, to really think about. These decision support systems. We already talked about the digital health case, which is highly problematic. But of course, these days we're already seeing developments of autonomous weapons, sometimes even making autonomous firing decisions. So that's another area where this type of high level of automation, well, for some, if you ask, a lot of people would argue should be banned outright. But it certainly needs a lot of control. And in this case, it becomes clear why this level of control is probably not just a thing for individuals working in this space to take responsibility and solve, but it probably takes a legislation approach as well. Right. There's the issue of deepfakes, again, to drive home the point of how important it is to be honest about a system and to communicate its capabilities, and also to really ask the question, where is it okay to use machine learning and AI, and to which ends, and where is it not okay? You're not allowed to forge a signature. So should you be allowed to forge digital videos of people saying something that they never did say or intended to say? This is a famous video you can also watch later with a deep fake of Obama. And this raises the question of trust, right? What can we trust? Can we trust individual systems outputs? And can we trust anything that is out there in terms of information these days? And there, it's of course a constant race of systems that produce these types of deepfakes, and then systems that can detect them, or sometimes people can still quite reliably detect them, but the edges there are certainly blurring. If you're interested in this whole problem space, then I can really recommend a couple of points here for further reading. And yeah, I know, because we just mentioned that the issue is often in the data, I want to do a quick detour into the data space before we get closer to the interaction for today. So when we talk about machine learning and artificial intelligence, and we discussed in the second session, really at least at a very high level, the standard model for ML and so on, of course, data is incredibly important. So we can ask, where does the data come from, right, for engineering these systems? And very often the data somehow can be fed back or fed in from users to begin with. But there are also other potential sources. One important development that really enabled this machine learning and AI boom that we discussed in the first session is the advent of broad-scale internet use and data becoming public and open in terms of open data movements and linked, and also people following quantified self and personal informatics movement, making data quite happily available, whether knowingly or unknowingly. So there was just a lot more data available to especially a couple of few big organizations to work with. It's important to recognize that data sensitivity is important to consider. So a couple of points here. I would always argue that almost all data is sensitive, right? A lot of data has fingerprint character, for example, movement patterns of an individual, or I don't know, even patterns in how you write can have a fingerprint per character if you have proper association with an individual. There's also this point in the domain of digital health that I work a lot in, that the big companies who are building these digital health platforms are saying basically all data is health data. Yes, there's obvious stuff like measuring a heart rate and so on, but also just trace data of how you interact with your smartphone can tell you, for example, about whether somebody is fatigued or may have depressive issues, depending on who they connect with on social media and which platforms they use. So this is really important, that we easily dismiss some data as not being sensitive, but a lot of data is. There's, of course, the issue of extracting data from models as well. So these model inversion attacks. I don't want to get into detail here, but that's the whole idea when you release a machine learning model and you think, well, the original data, which may be sensitive because maybe it was collected all over the internet and we just don't know, maybe that data isn't in that model. We just release the model and it's fine. But then given enough time and enough queries to a model, you can actually reconstruct surprising amounts of information from released models. So this is an example here with GPT-2. So that means when releasing data sets and models, actually differential privacy can be considered, but that's the whole idea of changing the data. So it's no longer the original data, but just still follows the same patterns and statistical properties. And there are, of course, issues with that as well, because you no longer work with the original data. Yeah, I mentioned the problem of humans in the loop potentially for discerning whether something's fair or not fair. And this also follows the whole idea of human computation, which is another point or another concept that is used a lot in how data is generated for machine learning and AI systems. So the whole concept of human computation was sort of invented and made popular by Louis Fanon with the ESP game, which was about sort of two people looking at an image. Before image classifiers were so successful that this is no longer necessary. Two people looking at an image saying, what's the key content of this message? They both type it individually without knowing the right answer. And if they agree, they get some points. And there were a lot of sort of playful and gameful interactions like this following that people engaged with a lot. And if you think about the data, this produces actually nicely labeled data for machine learning systems. And we see that pattern a lot. That in problem spaces that are difficult to compute, especially initially, and we listed some in a way earlier publication here, intuitive decisions, aesthetic judgment, contextual reasoning, embodiment issues. These are still difficult to solve for machines. And when you face these issues, we now very often see the pattern where people use human computation in the first place to solve a practical issue, maybe sometimes even in production, but then in parallel, they collect data so that eventually, given enough data and time in building models, the issue can be automated, right? We see that a lot, and there's obviously, if we talk about biases, fairness, and other ethical issues, there's the big ethical question of crowd work and gig work in general to consider here, which is often happily overlooked. Right. So this whole area of looking at where does data come from and how do people interact with it. Again, this is a super short excerpt from a longer lecture series, but there's an emerging field here as well, human data interaction, definition by Mochi et al. In 2014, saying there's a focus with this term on personal and open data. Establishing important key concepts such as legibility, so the process of understanding and making data and analytics algorithms both transparent and comprehensible to people. So you see here there's a very close link to explainability that we'll get to in a second. Agency, the power of handling data, capacity to control, inform, and correct data and inferences. It's a very interesting link there to the last session, this whole automation and control debate. And also negotiability. So to see the control over data and sharing of data as a dynamic relationship that emerges and that requires that we understand the attitudes and as they change over time and give the opportunity to reevaluate I can only point you to the works of Jack Holt and Alex Boyer, for example, from my last place of work, Open Lab at Newcastle University, doing really, really interesting work, both around GDPR and when you use it to do data request, is the data that you get actually telling or is it not, and what maybe needs to be changed. And Jack Holt doing this fantastic work around when people lose control, often towards the end of life, over their own data, what then happens to it, and how can we reevaluate our situation maybe. Oh yeah, this is actually an example from this paper I just mentioned about GDPR, which of course addresses some of these concerns that you just saw from Mortier et al. Yeah, we just released a study where we show that yeah, a lot of GDPR requests still don't even get a proper response, and if they do get one, the data is most often not telling at all to people. It's random formats that is very difficult to deal with. And yeah, this can really hurt the trust relationship, if you want, between people who offer systems and the stakeholders. And on the other hand, this study also shows that if it's done really well, this can also be a plus in the customer relationship. But anyway, this is just a pointer to some ongoing research. There's a larger development arc here going on behind the scenes with this whole human data interaction scene, where there's a strong argument that we should move from few data silos controlled by few big players to more personalized individual data pods, where we as individuals can decide when do we make which data available to whom. So there's this concept is also discussed under the term personal data vaults. There are just a couple of links for you to follow up if you're interested. So the whole idea there is, of course, to then empower the individuals by providing a right to full self-determination regarding personal data. And I think this is really important. You often see this quote, data is the new oil. And if that is so, then we really need to be thinking about giving asset ownership, our data, away to others, where we can then, they process it and we can buy some benefits back if we're lucky enough to be able to afford that. Yeah, it's a really important area, and it also brings some very interesting machine learning and AI engineering challenges, how you can interact with such data pods and still build and improve meaningful models. Yeah, but not to get too much into that. This is just a link again to another series of projects really coming out of Open Lab, my last place of work, that links to this whole idea of making also the methods for data processing more accessible. So there's a movement saying we don't just need open data, like open governmental data sets, for example. We also need to democratize data science, i.e. the processes for doing something meaningful with that data. If you're interested in this area, there's some fantastic work to read up by Are Pusar and others. Right. But this was the whole sort of there's this whole space of people thinking about data as the sort of the underlying fundamental thing that drives a lot of the recent developments next to methods development. And I just wanted to take you on a small detour, but back to fairness. Yeah, there's this whole concept of procedural fairness in terms of baking principles into AI and ML systems. If you want to achieve this procedural fairness, decisions arguably must be accurate. So you need to think about how you deal with data that is not in your training data, or whether you need to collect additional training data. For example, establishing credit scores for immigrants. And decisions must be fair. So the same outcome, if you think about it, may be unfair depending on the situation. Yeah, mentioning here the situation. Normally, maybe you shouldn't get extra late days compared to others on your assignment, but what if your dog just died? Should you then get them? It's very difficult to bake such decisions into a system. So there's this human interpretation component, and then you need to think about that from a human-computer interaction point of view. And yeah, the decisions should also be ideally consistent. And we just discussed in a whole session how that is difficult and unusual with systems that are dynamic and have unpredictable outputs. But there are, of course, strategies at least to test whether a small change in input leads to large and unjustified differences in outputs. And then we spoke about this whole thing that errors are almost impossible to prevent. So do you then have good recovery and repair strategies? So correctable is the concept here. And just to drive this home with another practical example, this is a system that does one of these automatic sort of candidate assessment scores in a hiring situation. And this is one of those spaces where, at least for some time, around 2 or 3 years ago, there were, and it's probably still going on, there are a lot of organizations popping up promising to really automate aspects of assessment and judgment in the hiring process. And yeah, there's a much cited work here by Raghavan et al. Really taking this concept apart and talking about mitigating bias in algorithmic hiring. Yeah, one of the points there is really to beware of AI snake oil. So you see here a lot of companies popping up in this space and the volume of funding they receive. So this is just to say there are a lot of organizations in any application area really of machine learning and AI these days that promise things that are quite outlandish. So it's good to keep a rough compass of sort of current day AI and ML capabilities in mind. So yes, in perception, there's really rapid, legitimate process. Yeah, image recognition, voice recognition, natural language translation, and so on. In automating judgment, such as spam detection, essay grading, and so on, there is measurable progress, but there are also stark imperfection, and there's always the interpretation and contextualization problem here. There isn't such an easy objective truth as with perception tasks. And then it gets really fishy in the whole space of predicting social outcomes, anything like job success, policing tasks, like we just mentioned earlier, terrorist risks, etc. Yeah, in most cases there, you can easily argue how manual scoring rules are just as accurate as any sort of black box system. And then, of course, they are more transparent. They're still highly questionable because they rely on data foundations and assumptions, but that are difficult to get right. Yeah. So just sort of thoughts to take with you here. AI and ML, data ethics, and data ethics is sort of an inseparable conundrum. Yeah, I just mentioned this data detour because of that fact. And there's a very complex relationship between ethical issues as well as policy and legal concerns, and also commercial concerns in this space. So that would require a few additional sessions to properly cover in detail, just to say that there are these different angles, lenses really, which you can take to look at this problem space. There's also a decisive local global problem. Because of the scalability of digital systems, we often have diverse teams spread out sort of across the globe. And they develop systems that get used in specific situations with individuals, and oftentimes it can really have a big impact on individual lives. But through this sort of separation and scalability, responsibility arguably can easily diffuse. And we just built the system, we thought it's for this purpose, and then suddenly something goes completely wrong. There's, interestingly, but this is a little bit of a provocation as well, also a dual relationship, arguably, eventually, where we may need to think about ethics for AI. But I don't want to diverge on this too much. But there's, of course, this whole debate. Does consciousness arise? And, at what point do we need to take responsibility for a neural network, for example? But yeah, if you're interested in this whole problem space, there are a couple of really highly recommended resources to follow up with. An excellent MOOC, an excellent practical introduction on biases and fairness, with lots of executable examples. I want to move briefly into the second part where we have most of the interaction today as well. So explainability as one of the potential mitigations for all that uncertainty that is needed if you want to get humans involved in making sure that systems function fine. Of course, you could argue explainability has its ancient roots in data visualization, which was already trying to make sense at least of the dataset part, if not the decision-making part of modern-day ML and AI systems. Is of course the godfather of data visualization, Edward Tufte, to look at some beautiful books if you ever find the time. Why do I think we should consider visualization in human-AI interaction in the first place? It's a discipline with a longer tradition, and it has some really interesting learnings to take lessons away from. And just in general, we can say that visualizations can, in the first place, even often eliminate or reduce the need for AI. If they are done well, they can explain data sets without much need and enable sort of people to take learnings from them or potential actions without a lot of potentially black boxy translation. So it's worth thinking about, can I solve my problem about making data useful even without a machine learning and AI system? Visualization can also be incredibly helpful in visualizing models or exploring data and outcomes when building models. Then there's a sort of flip side of the coin thought. AI then in return can also help us with creating better visualizations, especially in very complex data spaces, and decision trees can be one sort of quick example to drop in here. Right. It's also interesting to observe that the typical data processing pipeline established in data visualization reads very, very similarly to machine learning and AI. And there's also this learning that most of the time often is spent in data cleaning, transformation, integration, which is just a good sort of motivation to link to this whole concept of data excellence, which we need to foster if, across different projects, we want to keep building better ML and AI systems as well. There's an interesting point to link back to the last session again. If we have systems with uncertainty, that's not necessarily a bad thing, but we may want to think about making that transparent to users. Here you see an example of, I think this is a bus schedule, and they don't actually render out, the minutes or the time when a bus should arrive, but they actually give you a frequency as a sort of probability distribution, which, I don't know, maybe it's a little bit geeky, but it certainly gives an idea of the certainty in which usually one should expect the vehicle to arrive. Of course, you can also ask the question, isn't it more straightforward than to simply render out where the bus is right now if you have the capability? But anyway, that's this whole direct manipulation versus smart systems debate again. So explainability in the general concept, of course, it really depends on the type of machine learning and AI system you're talking about, the types of inputs and outputs it has. But the general problem is that very often we have, for example, in neural networks, this sort of black box type of a system where we train it with inputs and output labels, and then we give in another input and we get some output. And we don't really exactly know why. The system just says this is a cat, whereas in reality, we might want to understand how the system does this, and it may differentiate by looking at fur, whiskers, and claws, and so on. But most systems don't put this out. So this is some pointers if you want to follow up with interactive visualizations on developing a little bit of insight into this sort of how systems can differ depending on inputs and outputs. But it's interesting with explainability that GDPR basically already mandates it, and there are now some follow-up regulations making this even more clear. It stipulates the right to obtain meaningful information about the logic involved, commonly interpreted as a right to an explanation for consumers affected by an automated decision. So explainability is basically already in the law. Still, it's a developing field, and there's no clear agreement about what counts as an explanation or proper explanation or what it entails. And yeah, maybe it's interesting to see that this term already emerged in the 80s during the expert systems wave we mentioned in the first session, but it's now really seeing a revival. And of course, yeah, depending on the method, you have different approaches. As I said earlier, there's a social motivation to do well here. There's a sort of a moral obligation, but it's also can be seen as a commercial motivation, really, for organizations to do well in this space, as I mentioned earlier, where we saw how organizations respond and behave in the automated decisions and processing space can really change the customer relationship too. But yeah, it's also there's another pattern that we see a lot these days where people use very superficial, not really meaningful or helpful explainability features to a system and then use that as an excuse to say what the system does is fine. And that's, of course, not the case. Just to get to the interaction, this is probably the most commonly model or approach in explainability that you see. So these are SHAP values, Shapley additive explanations. They render out in sort of standard supervised machine learning systems the impact of each feature in the system. They basically are an interpretation of the impact of having a certain value for a given feature in comparison to the prediction if that feature just had a baseline value. So it's, this is just an example from a prediction where the team will have a player with a man of the match award, and you see from soccer, so passes, goals, saves, and so on, the team performance going in here. And yeah, higher likelihood giving or lower high likelihood giving features. And this is a very established system, and it's sort of an easy to grasp concept, but there are also some issues with it. And this takes us into the practical example for the session. So I will share a link in a second in the chat for everyone to play with. I suggest again that we do groups by sort of running into the different seating spaces. Groups of 2 to 3 are ideal, but you can also do more or less. You would need at least one person with a Google account or who is willing to do a dummy account, so you can use Google Colab. And what I prepared is a notebook for you. It doesn't really take much problem solving, but you can play around with it, of course. But it runs you through an example of producing SHAP values for a model. So that's potentially handy if you have never used it, and you can use this in the future for your models. But then it also takes you onto a little sort of journey of a critique of SHAP models and how we commonly use them and what might be an alternative approach. And I would be very interested in discussing this with you after you step through it.